Hello everyone. In this video we will learn how to calculate tail index using package called Regional Economic Analysis Toolbox. For this purpose I will use the same data that I'm always using it. I have two methods. The first method calculating tail index for each year, and then we gather all these years in one variable. So we will do this gathering for the two version, the weighted version and the non-weighted version. So this is the first data that I'm using, and the second code for the second method. I'm using the same package, but two different way. The ggplot2 is for plotting graphs, beautiful graphs and nice. I will start by introducing the method one. So I will upload the package reads. Unfortunately, this package is not disponible in the CRAN repository. So this is the package reads, collection of models and analysis. So this is the package that I'm using. Regional Economic Analysis Toolbox, collection of models and analysis methods used in the regional and urban economics and quantitative economic geography, measure of inequality, regional disparities and convergence, regional specialization, as well as accessibility and special attraction. And you can see that there is a different index. For example, this is the Atkinson index and the coefficient of variation. Calculate variation for the standardized and non-standardized, and the weighted and non-weighted. So to see the difference between this concept, weighted and non-weighted, I will explain this by using my data. For the weighted version, we will need to introduce the population number for each region. As you see in my data, I have two different kind of data, the GDP per capita and the number of population. So we calculate coefficient. For the weighted version, we introduce, as you said, we introduce the number of population, and for unweighted version, ou la version non pondérée, we don't introduce the number of population. So after explaining the difference between the two concepts, you can find also Gini coefficient, calculating Gini coefficient of inequality for the version standardized or non-standardized, and weighted and non-weighted. To see how to calculate Gini coefficient, just look out. You can find this the video that I'm introduced in the same channel. And also there is the hover index, calculating the hover concentration index with respect to regional income, for example GDP and population. And we have also Krugman concentration, or the Krugman coefficient for the spatial concentration of the two industries based on regional industry data. We have also the Lorentz curve. The Theil index that we will calculate today. Theil of inequality. This is a very powerful package. So as you see, this is the first chord. So to calculate this coefficient, we will need this package. I've already this package was deleted by run repository because of it didn't correct some errors. So you will find this package in the archive. I will leave this package down in the description. So to install this package, just go to packages and choose the R archive. So follow my steps. This is the package. Click in the open. So after that, click in install. I'm already installed the package, so it will give you this error. So I will pass this step. The second package is ggplot2. This package for plotting graphs, beautiful graphs. The third one is read Excel. My data is in Excel files, so I will use this package to import data into R. So run these three packages. I think I need to upload data again. So I will close the file Excel and try. Not yet. Not yet. No, it didn't work again. It's some technical problem that's so I will upload my data now. Run. View. This is my data. So this is my data. I have 12 region. So this is my data. I have 12 region. 12 region. It's Moroccan region. I'm using the GDP per capita, le PIB régional par habitant. So in my data, you will see that I have GDP per capita and I have population number. Unfortunately, I don't have the number of population from 2001 to 2004. So I will focus on the period 2004 to 2015. So I will calculate the first year. So as you see, In the unweighted version, I will use only this first section of data, just GDP per capita. I will calculate the Theil index, as I say, just from 2004 to 2015, and I will compare the results between the weighted and unweighted version. So I will skip this 3 years from 2001 to 2003. Now my first variable is called Theil4. It means the Theil index for the year 2004. This is the function that I'm using, the Theil. So you will see the function here, calculating the Theil inequality index. Theil, this is the function Theil. X is the numeric vector. So that's the X, the numeric vector in data. That's the X for the year 2004. That's a numeric vector for the year 2004. Weighting. So one weighting equals null. This is mean that I'm calculating the unweighted version or the unweighted coefficient. When I'm specifying the weighting equal null, this is mean that I'm calculating the unweighted. So as you see here, if I put the weighting equal null or I don't put it, it's the same code. So these two lines are the same. You will see this in result. I will compare the two results. You will see that the two results are equals. This is the result for the first code. The Theil for 2000 year equals 0.0166, and second line. So if these two lines are the same, they will give me the same result. So I need to change the name of the variable so to show up in this panel. So you see these two lines are equals. So I will repeat, if we put weighting equal null, it's the same if we don't put it in the code. So I hope this will help you to understand the difference. So I will pass now to the year 2005, 2007, 8, 9 until 2050. So as you see in this panel, I calculated the Theil for this period. So I will gather all this result in one variable. I will call it Theil unweighted. So I created the variable containing all this result. This step is just to help me to plot the variable and to see the evolution of this tail unweighted in function of year for the dynamic analysis, for example. This is my variable that I had created. It's a numerical variable. So after that I will create years. I will create a variable, chronological variable containing years from 2004 to 2015. So I will call this variable years equal a sequence of dates from 2004 to 2015 by years. So as you see results, I created the variable. After this steps, I will gather two variables. Now I will create a data frame contain the tail unweighted version and the year. This is the variable or the data. I will call it xt data frame with variable tail and years. So I will run it now. As you see, this is my data. Now I will plot the variable or the result of the tail index from 2004 to 2015 to help me to interpret the result in function of year or the evolution of this. How is the evolution of this variable? This is the years from 2004 to 2015. So you can see that the evolution from 2004 to 2000, you can see 2007 is stable. After that it goes down until 2008, and from 2009 to 2015 the evolution is increase rapidly. So to help you to interpret this graph for your data or for your own analysis, you need to dig in on the political economic policy economic and budget policy to see the policy that impacts the GDP and its distribution. As you can, as for example, you can introduce the impacts of the shocks. As you see now in my data, the economic crisis has impacted my data. Economic crisis of 2008. So the second step, I will explain the ggplot2 that I'm using. As you see here, ggplot, this is the data that I'm using, xt data that I had already created. The x, you will find the years, sequence of date. Otherwise, this is the tail index that we had already calculated. I'm using the function geom_line. This is the color, it's the hex code. If you want this code, just go to Google and type hex code color, and you will find all the codes, and you can change your color. So I'm using size 2, it's optimal. And this is the title, l'évolution de l'indice de T régional de 2004 jusqu'à 2015 pour la version non pondérée. So here it's from 2004 to 2015. So I will you can add subtitle here. La version non pondérée, c'est unweighted version. So moving now to the weighted version, as I already said, that we will need the number of population, the section number of population. So I will start by the first year, 2004. The tail weighted for the year 2004 is the function tail. This is the variable GDP per capita, the regional GDP per capita. The weighted, here I introduced the variable number of population for the year 2004. So we run this code. This is the result. Tail weighted for year 2004. It's a negative. So we'll do the same thing for the sequence of year from 2004 to 2015. As you see, results are showing up in this panel. Now we will gather all these results in one variable called tail weighted. So the variable, now this is the variable tail weighted. After that we will create a sequence of years. Create a now time period, years. It's the same code that I'm using. It's just changing the name. Data frame now YT. I call the data as YT, containing the tail unweighted version and the years, sequence of years. Now we plot the graph. This is the graph. This is the graph. As you see, is different. L'évolution de l'indice de tiers régional de 2004 jusqu'à 2015. La version pondérée. Sorry, I need to correct this error. L'évolution de l'indice de T régional de 2004 jusqu'à 2015. La version pondérée. The two graphs are different. You can see that the number of population impacts the evolution of the tail index. As I said, to interpret the result, you need to dig on the economic policy of country or the region that you are studying. After we calculate the unweighted version and the weighted version, we can and after we plot the graphs, the third step is to save the data. For this purpose, we will use this code. If you want to compare these two versions of the index, you can plot these two graphs in the same graph, and you can compare the evolution of the two index. So we can finish by saving this data or these results in Excel file. So I started by creating years from 2004 to 2015. My data called contain years and the weighted version and the unweighted version of the index. So I called my data B. So you see the code: open Excel, write data file. So you will find this Excel file in the directory that you are working in it. I will explain this code. Open Excel, write Excel. We are writing Excel, so it means that we are saving my data here, B, data called B, and the title I called the Theil from 2004 to 2015. As you see, this is my directory that I'm using. You will see the Theil index here down, Theil from 2004 to 2015. So you need to look for the directory that you are using. So this is I open the Excel file. As you see, this is years and the weighted version and unweighted version. So I will plot this result to see to compare that it's the same results. So this is the unweighted version. So I will plot the unweighted version. Just select the results, go to insert, graphs, look for graphs that showing the evolution of variables. So I will change this variable to introduce the years from 2004 to 2015. Edit. I'm editing now my data to select years. And now so this is my data. This is the unweighted version. It's the same graph that's R plotted, shows the same evolution. Now we plot the weighted version. This is the unweighted version, so I will introduce the years. I'm editing now my data to introduce here. So you can see that the evolution is the same. It's the same evolution of the weighted version. You can see. As I said, if you want to compare between the two versions, you could plot this two version in the same graph. For example, for this graph, you can add the weighted version to the unweighted version. So